Hey guys, welcome back. This is simple harmonic motion part 4. Two blocks are connected to identical ideal springs and are oscillating on a horizontal frictionless surface. Block A has a mass m and its motion is represented by the graph of position as a function of time as shown above. Block B's motion is represented above on the right. Which of the following statements comparing block A to block B is correct? So what's going to be the same if they are the same identical ideal springs? Little k is going to be the same. Block B covers more distance per cycle than block A. Block B takes more time to complete each cycle. Because block B covers more distance per cycle, we know that that doesn't matter because displacement isn't in our formula, right? That's not something we're looking at the formula of a mass spring. There's nowhere to put x in here, so that's not the case. B, because the spring attached to block B is initially stretched greater distance, the spring constant is smaller. We know it's the same, so that's not right. Because block B has more mass, it has a slower average speed than block A does. And D, because block B has more mass, its acceleration is smaller than block A at any given displacement. What your average speed is going to be related to not only the mass, but how far you displace it as well, right? And so D is our correct answer. We know that MA would be equal to negative KX, and we know that K is the same. And so if B is bigger, then his acceleration would be smaller at the same X. All right, so the top curve is the graph of the previous equation. The bottom curve is the same but shifted a quarter of the period so that the sine function is rather than a cosine function. So we saw this. I showed you that when I did the beginning of the lab, where we have sine and cosine. For the most part, we're going to look at cosine because it makes more sense for us to displace it and then let it go. Okay, so going from distance to velocity to acceleration. And I did this when I did the derivation, and I said that the derivative of cosine was negative sine, and the derivative of sine was cosine. So how can you do this if you don't know calculus? You can look at the slopes, and that's what I'm going to try to show you guys today. So looking at this, the easiest places, if we remember, this is displacement and time. The slope gives us velocity. So the easiest thing to do is look at places where your slope is 0. So where is my slope going to be 0? There at 0, there at 0, there at 0, there at 0. So these are going to be places where our velocity ends up being 0. So we just plot those down here. And then I want to look at what's going on with the beginning of my graph for position. So when I look here, it starts off with a slope of 0, and then my slopes start off being negative. So this right here would represent a negative slope. So that means that I need to have a negative slope to start with, and I'm just going to fill it in. All right, to go from velocity time to acceleration, the velocity time slopes give us acceleration time. So again, where is the slope 0? The slope is 0 there, 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 and there. And then I'm just going to plug these in. So I put my 0 point at t over 4. We have one at 3/4 t. We have one at that point. And then again, looking at our slopes here, now we don't start off at 0, but this starts off with a negative slope. So when I graph that down here, I'm going to start negative and then go to positive. So it's going to line up the whole time. Now, we're identifying this as cosine. This first one's cosine. So x is equal to a cosine omega t. We know this one is negative sine. We don't know what these values are, but we can find them out from our amplitude by taking the derivative of this, and the derivative of this gives us that v, which is going to be x prime, is going to be negative omega a sine omega t. So this displacement, v max, this amplitude is omega times a. And then I know that acceleration is the second derivative of this, and the derivative of sine ends up being cosine. So this is going to be minus omega squared a cosine omega t. And so I know that a max, the amplitude of this one would be omega squared a.